Hello everyone, this is Rambuyan Christian Jopatsi presenting pulse amplitude modulation. Pulse amplitude modulation is the basic form of pulse modulation. In this modulation, the signal is sampled at regular intervals and each sample is made proportional to the amplitude of the modulating signal. First, let us remember the definition of modulation. Modulation is the process of changing the characteristics of a carrier signal like amplitude, frequency, and width. Now, let us move back again to PAM or pulse amplitude modulation. It is a technique in which the amplitude of each pulse is controlled by an instantaneous amplitude of the modulation signal. It is a modulation system in which the signal is sampled at regular intervals and each sample is made proportional to the amplitude of the signal at the instant of sampling. This technique transmits the data by encoding the amplitude of a series of digital pulses. In PAM, there are two types of sampling techniques, the flat top and natural PAM. In flat top pulse amplitude modulation, the amplitude of each pulse is directly proportional to modulating signal amplitude at the time of pulse occurrence. The amplitude of the signal cannot be changed with respect to the analog signal to be sampled. The tops of the amplitude remain flat. Now in natural pulse amplitude modulation, the amplitude of each pulse is directly proportional to modulating signal amplitude at the time of pulse occurrence. Then follows the amplitude of the pulse for the rest of the half cycle. Now what are the applications of pulse amplitude modulation? It is used for Ethernet communication. Now Ethernet is a computer network technology which is used in different area networks such as LAN or local area network, MAN, and WAN, and more. Ethernet connecting computers together with cables so the computers can share information. Also, it is used in many microcontrollers for generating the control signals, and PAM is also used in photobiology. Now, photobiology is the study of the effects of ultraviolet, visible, and infrared radiation on living organisms. It is also used as an electronic driver for LED lighting. Now, let's move for the advantages of using PAM. PAM, it is a simple process for both modulation and demodulation. Transmitter and receiver circuits are simple and easy to construct. PAM can generate other pulse modulation signals and can carry messages at the same time. Now, we will be building the circuit using ISIS, Proteus, a professional software. ISIS is the software used to draw schematics and simulate the circuits in real time. The simulation allows humans access during runtime, thus providing real-time simulation. ISIS has a wide range of components in its library. It has sources, signal generators, measurement and analysis tools like oscilloscopes, voltmeter, ammeter, and more. Probes for real-time monitoring of the parameters of the circuit, switches, displays, loads like motors and lamps, discrete components like resistors, capacitors, inductors, transformers, digital and analog integrated circuits, semiconductor switches, relays, microcontrollers, processors, sensors, and more. Now we will begin designing the circuit to show the PAM. Let us discuss about the 555. The 555 can be considered a oscillator circuit and its activity. The 555 IC can be used to create a free-running, stable oscillator to continuously produce square wave pulses. But we can also connect the I55 timer IC in an unstable mode to produce a very stable 555 oscillator circuit. generating highly accurate free-running waveforms whose output frequency can be adjusted by means of an external connected RC tank circuit consisting of just two resistors and a capacitor. Now let us discuss about 416. 416 component. This 416 is commonly used in multiplexing application. It can also be used to isolate signals. The switch is bilateral and hence can be used for both digital and analog signals. The IC can operate from 3 volts to 18 volts but commonly operated at 5 volts, 10 volts, 15 volts nominal voltages. You can switch voltages up to 20 volts. The 416 can be also said as quad bilateral switches, has 4 bilateral switches that can be controlled independently using a digital signal. Each switch has 2 input and 4 output pins called SWX in and out, both of which can be used as input or output pin. They can also be used to switch variable voltages like PWM wave, sine wave, and others of low magnitude and frequency. These 2 pins will be controlled by the control X pin. The component here in ICs called Deus 8 shows one of the 4 switches in the IC. As you can see here, there are 2 switch pins named X and Y, and the control pin is named as C. By default, when the control pin is logic or in 0 volts, the switch is open or not connected. But when a control signal is given, the control pin C, the switch closes and the LED glows. So let's continue once again. Now for our finishing touches, we will now be adding the oscillator and the signal generator. Now we will be adding a ground, the negative side or negative component of the generator. This is to provide a better sine wave. Began simulating it. Now this is one of the other features of Deus 8 is that arranging it during simulation provide a better waveform result.